Right. Algebra 2, Lecture 125 and 126, OSA 2A17. The student will determine whether an infinite geometric series diverges or converges, and if it converges, they'll find the sum. Okay. Now, last week we talked about finite geometric sequences and series, and that means the sequence or the series has a beginning and an end. We're going to be talking about infinite geometric series today, and we're going to talk about converging and diverging. If an infinite geometric series diverges, that means that you just keep adding one term after another and it gets infinitely large, or if it's going in a negative direction, so to speak, it gets infinitely small. It doesn't approach any number. But if it converges, the sequence will approach a given number. I'll just do a quick example that might make sense. If I were to add all these numbers up, 1/2 plus 1/4 plus 1/8 plus 1/16 plus so forth and so on, I keep this pattern up infinitely. Every time I'm just taking half of this. I took half of this and I got a half. You take half of a half, you get a fourth. Times 1/2 is 1/8. 1/2 of that is 1/16. Times 1/2 is 1/32. So forth and so on infinitely. We can do that forever. If we look at it on a number line, what's happening? Let's say this is 0, and here's 1, here's 2. Okay. If we start at 1, and we're right here on the number line, if we add a half, now we're here. We move from here to here. If we add a fourth, now we're here. If we add 1/8, that's half of that distance. If we add 1/16, that's half of that distance. We're adding to it. If we add 1/32, that's half of that distance, and we can do that infinitely. And we'll get infinitely closer and closer and closer and closer to the number 2. You'll never really reach it, but the limit of this sum is the number 2. And that's how we define the sum of an infinite geometric series, is the limit of the number that's being approached, so to speak, a way of thinking of it. And so what I'm going to do, hopefully, is to show you whether or not, I'll show you how to determine whether or not a series diverges or converges. If it converges, it'll approach a number just like I just illustrated there. If it diverges, it'll get either infinitely large or infinitely small, and you can't find the sum. But if it does converge, we define the sum as the number that's being approached, so to speak. So here's how you determine whether an infinite geometric series diverges or converges. Find the common ratio. And if the absolute value of the common ratio is greater than 1, it's divergent. It diverges. And if it diverges, you cannot find the sum. This will get infinitely larger and larger. If you add 2 plus 4, you'll get 6 plus 8 is 14, blah, 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 go on and on. The number will just get larger and larger. It won't approach anything. But if we divide and find our common ratio here, we've got 3/2 divided by 3. We can think of that as 3/1. That's the same thing as 3/2 times 1/3. We invert and multiply the bottom. These will cancel, and that gives me 1/2. 3/4 divided by 3/2 is the same thing as 3/4 times 2/3. We invert and multiply. These will cancel, leave me with 2/4, which is also 1/2. So my common ratio, in this case, is 1/2. Since the absolute value of 1/2 is less than 1, we can say that this infinite geometric series converges, and we can find the sum. Or we can say it's convergent. Okay. So if we find the common ratio and it's bigger than 1, the absolute value is bigger than 1, then we say it diverges, cannot find the sum. But if the absolute value is less than 1, the absolute value of the common ratio is less than 1, between 0 and 1, then we can say it converges and we can find the sum. And I'm going to show you, now that we found out how to determine whether it diverges or converges, I'm going to show you how to find the sum, hopefully. Here we go. Evaluate an infinite geometric series. Both of these go on to continue that pattern forever. Infinite series. There's no end. There's a beginning but no end. Evaluate the infinite geometric series described. Here's our formula that we're going to use to find the sum of an infinite geometric series. You're going to take a sub 1. Remember, that means the first term in the series. You can find that just by looking at it. There's a sub 1 there. There's a sub 1 right there. Here it's telling us. Then we find r and we plug that in here. We perform this arithmetic, and this will tell us the number that's being approached. And that's how we define the sum. It's the limit of that sum, so to speak. So here's what we do. We say, if I want to find the sum of this infinite geometric series that's being described, it's described as the first term is 3/2 and the common ratio is 1/3. How do we find the sum? We use the sum of an infinite series formula. A sub 1, that's the first term, 3/2, over 1 minus r, which is 1/3. Now we've got to do a little bit of arithmetic. This is 3/2 divided by 2/3. 1 minus 1/3 is 2/3. Now if I've got 3/2 divided by 2/3, that's the same thing as 3/2 times 3/2, which is 9/4. So this sum, let me scooch this over to the left a little bit, is 9/4, which you can think of as this going twice with a remainder of 1, or 2 1/4. This infinite geometric sum converges because they're telling us it's an infinite geometric series. It is infinite geometric series, and we can evaluate it, so we know that it will converge. And it converges to 9/4 or 2 1/4. And I'm going to check my answer and see if I got that right. See if I can find my answers. 9/4, yay, I found it right here. Okay, so let's take a look at another one real quick. Let me kind of move this. We'll just say equals 9/4, or 2 1/4. 4 goes into 9 twice with a remainder of 1, 2 1/4. All right, let's look here. We have a finite or an infinite geometric series, and it does converge. I'm going to go ahead and prove that to myself real quick. I'm going to divide this by this, 5/3, divided by 5, which is 5 over 1. You can think of that as 5/3 times 1/5. We can invert and multiply. These cancel. This is 1/3. 1/3 is less than 1. It is a geometric series, but we'll go ahead and just make sure that it converges, that it does have 1/3 there. So 5/9 divided by 5/3 is the same thing as 5/9 times 3/5. And these cancel, leaves me with 3 over 9, which will reduce to 1/3. So my common ratio is less than 1. The absolute value of this is less than 1. So it does converge, so I can use the formula for finding an infinite geometric series. That's this formula right here. Okay? So I'm going to say the sum, I'll go ahead and write that right here. Sum is a sub 1 over 1 minus r. Having a difficult time this morning. A sub 1 over 1 minus r. This will yield 5, that's the first term, over 1 minus, and what did we say that was? 1/3? I think it was. Go back and make sure. Yep, 1/3. Helps to remember stuff. That's 5 over 1 minus 1/3 is 2/3. And I invert and multiply to find the sum. 5 times 3 halves. 5 divided by 2/3, so we invert and multiply the bottom. That gives me 15 halves. Or 2 will go into 15 7 times with a remainder of 1 half. So 15 halves or 7.5, unless I've made a mistake. 15 halves, yay! So we found that this was 1/3, and I forgot to write it down, and then forgot what it was, because I'm old. But that's our common ratio. We plugged it in here, plugged the first term in here, did this arithmetic, tried not to mess it up, and we got the right answer. Okay? Take a look at another one. Here we're using sigma notation. Well, what do we need? We need the common ratio, and we need the first term. So that's all I'm really interested in. I'm told in the instructions that this is an infinite geometric series. If I plug in a 1 here and then do this arithmetic, I'll get the first term. If I plug in a 2, I'll get the next term. If I plug in a 3, I'll get so forth and so on, and I'm going to do this infinitely. I'm just going to plug in bigger and bigger numbers, and this will converge. The instructions say that it's an infinite geometric series that's convergent, so we're going to find the sum. So here we go. I'm going to use this formula again. The sum is the first term over 1 minus r. So the first term I get by plugging in a 1. Well, this is -8 times -1/2 to the 1 minus 1. Now 1 minus 1 is 0. So this is -1/2 to the 0 power, and anything to the 0 power is 1. So this is -8 times 1. This is just a big fancy 1 right here. I said anything to the 0 power is 1. That's not exactly true. 0 to the 0 power is undefined. All the other numbers to the 0 power are 1. So this is -8 times 1, which is -8. So that's my first term. I plugged in a 1. I got -8. So my first term is -8. My r is this right here. 1 minus, I'm looking at r. It's a times r to the k minus 1. That's the basic form as we talked about last week. So here it is right here, just as a reminder. Okay. So, a sub 1, I'm sorry. A sub 1, first term, r, n minus 1. So r is -1/2. Now I just got to do this arithmetic and try not to mess it up. This is -8. This is 1 plus 1/2. That's 3 halves. You can think of that as 2 halves plus 1/2. That's 3 halves. That will give me 8 times, -8 times 2/3. And that will give me, you think of this as being over 1, it'll give me 16 thirds negative. So that's -16 thirds. Or 3 will go into 16 5 times. Still going to be negative with a remainder of 1. And hopefully I haven't messed that up. That'll be my infinite sum. Get rid of that scratch work right there. The infinite sum here will be either -16 thirds, which you can think of as -5 and 1/3. Either way is fine. And let's see if I got it right. -16 thirds, yay! So we just found a sub 1 by plugging in a 1 here and then doing the arithmetic. That gave us a sub 1 right there, -8. And then I plugged in r, which is this number here, 1 minus -1/2. Double negative is positive. 2 halves plus 1/2 is 3 halves. Did the arithmetic, came up with the infinite sum. Excuse me, let me drink a coffee here. All right, let's get this out of the way. All right, we got another infinite sum. It's in using sigma notation, or you'll hear it called summation notation as well. Summation. Let's see what we've got here. I'm going to find the sum by finding the first term divided by, that's a sub 1, 1 minus r. Well, I'm looking at r, so r is 1/5. I'm going to find the first term by plugging in a 1 right here. So this gives me 6. This is just scratch work here. Times 1/5 to the 1 minus 1 is 0. So this part right here is a fancy 1. Anything to the 0 power is the number 1, with the exception of 0. 0 to the 0 power is undefined. So this is 1 times 6, which is 6. And that's my first term. So I'm going to say the sum, this infinite sum, is 6. 1 minus r is 1/5. This 1 is like 5/5. 5 over 5 is 1. So I'm thinking 5/5 minus 1/5 is 4/5. So that gives me 6 over 5/5 minus 1/5 is 4/5. And I do this arithmetic. This is 6 times invert and multiply, 5 over 4. And 6 times 5 over 4 is 30 over 4, which will reduce to 15 over 2. You can divide top and bottom by 2. And there's our answer, 15 over 2, or 7.5. 2 will go into 15 7 times with a remainder of 1. So our infinite sum, let's see if I can scroll down a little bit more, S is 15 over 2, or 7 1/2. Okay? And that's what we're doing here. And I'm going to check and see if I got that one right. 15 over 2, yay! So once again, if we're given, and they're giving us an infinite geometric series and they want us to determine whether it converges or diverges, just find r. If the absolute value of r is less than 1, it converges and we can find the sum. If it's greater than 1, then it will diverge and we can't find the sum. This would just get infinitely larger and larger and larger. We can't find the sum. This converges, so we could find the sum. And the formula, right there. You can do this.